Welcome to the continuing celebration of the Keller Center, inauguration of the Keller Center. This next hour and a half, we're going to hear from 5 very distinguished educators in engineering. We have, in particular, Linda Abriola, who's the Dean of Engineering at Tufts University, Dave Munson, who's the Dean of Engineering at the University of Michigan. Dave and Linda are both graduate alumni of Princeton. We also have Jim Plummer, Dean of Engineering at Stanford University. Subra Suresh, Dean of Engineering at MIT. Kyle Vanderlick, Dean of Engineering at Yale. Kyle is also a faculty alumni, former chair of chemical engineering at Princeton. She taught me a lot about the Princeton administration when I first became dean. So we're very delighted to have you all here, and thank you for coming. Looking forward to what you have to say. So let me just say a little bit about the format. We have an hour and a half for this panel, and what I thought we would do is first, I have 5 questions, which I'll read to you in a second, and I'm going to ask. We've all talked on the phone about these, and we've sort of divided the questions up so that 2 deans will be addressing primarily each question, and then others, of course, can add comments as they like to the discussion. So it's fairly informal. So that'll take about an hour, and then we'll open it up to questions from the audience and discussion from the audience. So we have about an hour and a half. We'll be done about 4 o'clock. The 5 questions are this. They're not really questions, they're issues. The first issue, very appropriate for today's setting, is engineering in a liberal arts setting. Second question is engineering and globalization. Third, interdisciplinary teaching. And in particular, the suitability of existing academic structures for that. The fourth is integrating research and teaching. How do we bring the excitement of research to our students? And finally, engineering and entrepreneurship. And these 5 topics are all things that are very much at the heart of what the Keller Center is involved with, and so that's how they were selected. So why don't we just kick things right off and go and talk a bit about engineering in a liberal arts setting. How do we teach liberal arts students engineering, and how do we teach engineering students the societal issues facing them and relating to what they're doing? And here, Linda and Dave have agreed to be the formal speakers, and Linda, will start with you, if that's okay.
Okay, well, I'm delighted to be here. It's been a long time since I walked around the campus, in fact, 25 years. Lots changed. This was a parking lot when I was here, but it's beautiful, and it's great to be back, and some of the places still are there, like A&B used to be my favorite place to eat, and that's still around, and Landau's and Hewlett's, and anyway, it was walking down memory lane last night. I've been asked to address the liberal arts, engineering in a liberal arts setting. I'm a dean at Tufts, and Tufts, in many respects, has a similar profile to Princeton. It's an engineering school that's really embedded in a liberal arts college, which is within a research intensive institution, so that there are a number of professional schools as well. So this allows us, I think, already to attract students who are interested in combining engineering and other disciplines in liberal arts. Our students typically have very broad talents, and that's an advantage. So what my comments here are going to address things that are going on at Tufts and ideas that we have, but I'm not sure how exportable they are to different environments. The other thing that we can do, we're very closely tied with arts and sciences. The engineering population is about 15% of the student body. The buildings are actually all integrated, unlike how Princeton's evolving. We are very much closely knit with the sciences, and we're close to the liberal arts as well because we're relatively small. So our students tend to take double majors. It's very, very common, and double majors are encouraged. We have a 0 net attrition in engineering, so as many students come from the liberal arts into engineering as leave. And I think it's part of our willingness to fashion degree programs. We're not always wedded to the ABET curricula. If our students want to experiment, we allow them to do so, and we have a number of different options for them. So while we have a number of ABET accredited degrees, we're not limited by those. And I think that's important when you start to look at these issues. The other thing that I think you need to do in this kind of setting is to build on the strengths of the institution. So, for instance, as you have the Woodrow Wilson School, we have the Fletcher School of Diplomacy, and International Relations is the largest undergraduate major at Tufts, which is across, it's not a department, it's across departments. So we get a student body that is very interested in the global picture. So we're trying to build on that by giving them experiences, giving them opportunities. Another example is that we have a nutrition school. And so we have a lot of opportunities to wed the engineering with public health, and we have a lot of interesting programs. So you have to look for those kinds of opportunities and encourage your students to explore them. We also offer, and I think that's true here as well, we offer what we call half credit, but they're essentially half courses in sexy topics. Building skyscrapers, gourmet engineering, and they're open to, and they count for distribution requirements for the liberal arts students. So they are encouraged to take those as part of their curriculum. So we do have a lot of flow back and forth. But it's been less successful than I thought in attracting students. They tend to come knowing they want to do engineering, and I haven't found a lot of liberal arts students coming to engineering because of those courses. They tend to take them more in their senior year. So it's an imperfect model, I think, at this point. And I think the other thing that's really important is to let creativity flourish. We have an X-College, which creates courses outside of the curriculum. And a number of courses have been created in the X-College by faculty who are partnering that end up then coming into the curriculum. And it's an interesting model. I don't know if many schools have that. We are blessed by the culture at Tufts, which tends to be the faculty governing body is joined. Arts and sciences and engineering are joined together. And so faculty governance is together, tenure and promotion is together. There are many joint appointments, and so that culture encourages this sort of education. And we do have administrative support from above for this kind of activities. I think the impediments are on the liberal arts side. I still think there is a lack of appreciation for technological literacy. I still think that we have a ways to go to communicate the importance of this, and as Norm Augustine said this morning, it's so important. And I think in this case, our students are our best spokespeople. When they take classes in these other disciplines, and they get engaged in the problem, the students start to appreciate what they're bringing to bear, and I think they're the best advertisement for the importance of technological literacy. And I think the other thing is there have to be fiscal incentives for this kind of experimentation, and unless you establish those incentives, I don't think it's sustainable, and that's one of the things I face as dean. So those are my comments.
Yeah, thanks, Vince. First of all, as Linda said, it's wonderful to be back. I hadn't been back for a number of years. I did notice that the Nassau Inn is still here, Hoagie Haven is still here, and so I guess the world is okay. But seriously, it's a thrill to be back here and meet a lot of folks that I haven't seen for a while. Earlier in my faculty career, I was really pretty interested in establishing something at the intersection between engineering and the arts. I see a lot of connection there, and I'll address that in just a second. And it was about 2 decades ago or so, maybe a little bit less, maybe a decade and a half ago, there were a number of liberal arts schools in New England that were going out of business. And I thought, darn, this is a time to be entrepreneurial. If I could just find somebody with a lot of money, I could establish some sort of institute for engineering and the arts. Well, that didn't happen. At the time, I was a faculty member at Illinois. But 6 years ago, I moved to the University of Michigan, and it turns out there that engineering is sort of segregated from the rest of campus, if you will. We're up on the North Campus, but we have neighbors. The other people we share the North Campus with are every single arts unit. And so it's music, theater, and dance, architecture, and art and design. And so with me as dean, our faculty don't have a choice. Engineering is working with the arts. We're going to do that, and we are doing that, and I'd like to talk about that just a little bit. What I see among our student body is the vast majority who enter engineering, those kids are musicians, artists, etc. That's just a fact if you look at their records. And so there's no reason that we ought to shut that down when they start engineering. I also see a complete parallel between engineering and the arts. On both sides, there's a strong element of creativity, and that's the side that probably we think about the most, but there's also a strong element of refinement. A musician may be somebody who is improvising in jazz, but more likely that musician is learning how to play Bach or Beethoven better and better and better. And it's their own interpretation, but still better and better and better. And that really describes an engineer in terms of optimization and trying to do things in the best way for your employer or for society. So I think those parallels are there. On the engineering side, if you look at the products that engineers create, whether it's an iPod or an automobile, a lot of times the value add there, the really distinguishing characteristic is unfortunately not on the technological side. I say that as an electrical engineer. You look at an iPod. Why does an iPod sell? Is it because it has a better MP3 decoding algorithm? No, they're all pretty much the same. Better chips, better integrated circuits? No, they're all pretty much the same. And you really have to admit, it's the way it looks, it's the way it feels, it's the materials it's made out of, it's sort of the pizzazz, it's the easy download from iTunes and all of that, right? Well, so that has a lot more to do with design, and maybe the design ought to have a lot more to do with engineering. The same thing is true of automobiles. Really, the automotive, quote, manufacturers now are just system integrators. And you can buy a transmission from anybody, you can buy batteries from anybody, you can buy the electronics from anybody, et cetera, et cetera. And I think there's increasingly a lot of customization being done in terms of the consumer options there. So I see a lot of connection between engineering and the arts. I think we have students that start in our institutions in engineering with an enormous amount of creativity, and what we used to do in our engineering curricula anyway was do our best job at stamping that out. It was homework, 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 and the homework's necessary, but it's not enough. So the question is what to do, and I won't address this completely in my couple minutes here, but at Michigan we've got plenty of students who double major, and we've just instituted a number of minors, and now it's possible for any student in engineering to get a minor in art and design, a minor in music, a minor in architecture. We're also doing some co-teaching. We've got engineering faculty helping teach some of the courses. In architecture, for example, we've got a course on creativity we're teaching this semester. It has 2 faculty from engineering, 2 from art, 2 from music, and 2 from architecture, and students from all over campus in that course, so it's a multi-section course. Huge student project component there. Speaking of student projects, we're working very hard on multidisciplinary design projects, great big imaginative things. So not the traditional senior capstone design experience in engineering, but something way bigger. We have scads of these, and I think this is the trend at all leading engineering institutions, including this one. Just as an example, we have a group of students that decided they wanted to bring the internet to the entire continent of Africa. Well, that's pretty ambitious, and how would you do it? Africa doesn't have much infrastructure, and I should be a little cautious there. Africa is not completely homogeneous. Obviously, there's a lot of countries and a lot of differences there. But the students, for their project, designed a satellite ground station, and then the idea was this would be solar powered because there wouldn't be electricity in the village where this thing resided. And then if there were just one laptop computer in this internet ground station for that village, it perhaps could be transformative. But the students did more than design it. They actually built a bunch of demos. They actually flew over to Africa. They actually installed it. And the stuff is all operating now, and now the students are looking for corporate sponsors. The next thing they'll have to do is get the price down, because the price is around $4,000 for one of these stations. They need to get it down to around $1,000 or so, and then they think that can really spread across many countries over there. But that's just one example of dozens that I could comment on, and I think these kinds of things are giving our students real-world experience. And by the way, there are a lot of these projects that involve students from outside of engineering with engineering students. And for me, there's nothing that I prefer to see. At least at my place, we're making joint faculty hires between engineering and the arts units. And so the fellow who was recently hired as a professor of campanology, he's the person that instructs, runs the program on how to play the carillon. Actually have a couple of carillons. And he's got a partial appointment in engineering. It's not a zero-time appointment, it's a real appointment, and he's going to be teaching courses on the physics of bells and that sort of thing. We have another offer out right now to a faculty member who will be joint between computer science and music, and is at the intersection there of in performing arts technology. We're also doing a lot of fun things together between the engineering students and the art students. I won't describe those things right now, but we claim we're having more fun than anybody else on campus. So.
Engineers always do. Anybody else want to make any brief comments on this topic? Okay, super.
Before joining MIT as a faculty member, I was a faculty member for 10 years at Brown University in engineering. And that's, if I could describe an experience that's very different from my current experience of being an engineering faculty member, department head, or dean in a place like MIT, Brown and MIT probably span the ends of a very broad spectrum. One of the things I realized at MIT is the ability of students in the arts, ability of engineering students in the arts. It's just incredible. There are no, I don't know the official numbers, but something on the order of about 65% of the undergraduate students have well beyond the average ability in music, in playing one or more instruments. And I feel that given the time pressures and the infrastructures that we have, that potential is not fully tapped yet. There is so much more we could do, not just in an engineering-based school, but also across the country. And that's just one observation that I would like to make. The second observation, going back to David's point, is that the media lab at MIT was set up as sort of an interface between engineering and products going into the marketplace. And a lot of the things that happen in the media lab are what engineers do in departments like electrical engineering and computer science, or robotics and so forth in mechanical engineering. But at the same time, you also have elements from other units that are brought into it. And that can pervade not just one particular center or lab, but across a campus. So there are many, many models one can think of where something like that could be facilitated.
Actually, if I could just build on that, I mean, one of the experiments we tried at Stanford 4 or 5 years ago was something we call the D School, or the Design Institute, and it's really it was founded by one of our faculty who was also one of the founders of IDEO, which is a world-class design firm. But the concept was that historically, senior design projects, when many of us were in school, would, you know, if I'm a double E, so a senior design project was get 5 double E's together and we'll all work on programming a little microprocessor on a motherboard or something. You know, it's a double E-ish kind of product. And that's not how it is in the real world. You know, if you really design something in the real world, then there are technical issues, but there also are human factors issues, and there are very important business issues as well. So the concept for I think this is what's happening at Michigan and MIT and other places. So the new kind of senior capstone design project is to create a team of people where the students are drawn from the business environment, they're drawn from the liberal arts, the humanists and the ethnographers and so on, and they're drawn from the engineering school. And they work together on a project, and the one you cited about the project in Africa is a great example, that this kind of thing is happening everywhere, and it gives the students a very different kind of real-world design project. And more importantly, I think, it's one of the few ways I've found to get students outside of engineering into an engineering environment, you know, because they'll come in as domain experts. You know, engineers don't know much typically about human factors. They don't often know much about business. So the business students or the humanists who come into these teams are the domain experts in the team that's put together. And so they're not like outsiders, you know, they're really part of a critical part of a team. And that's, to me, the key to getting all these different disciplines together. Have each player think that they are the expert in what they do, and they're coming together to do something that not any of them could do separately. And so I think that's actually a good way to think about how to bring liberal arts into engineering and vice versa.
The point I was going to make, and everybody touched on it, was I think the importance of design that's coming into engineering education at all levels. Through the graduate program, that's what the D School, I think, focuses most on, but in particular, building design experiences all the way down into the freshman curriculum, into the freshman level, gives a chance to expose engineering to non-engineering majors, to get engineering majors psyched up about the discipline. And I think we're all thinking about new ways to do this. And I think the focus on design especially is what's going to separate engineering programs from the science programming, and is going to be incredibly important to the discipline.
Thank you. So, outstanding points. Let's move on. We can come back to this later when we take questions. This is perhaps at the center of the discussion is this relationship between engineering and the liberal arts. But let's also talk about globalization. And so the next topic is engineering and globalization. And Jim and Subra are the designated speakers on that. So, Jim, why don't we start with you?
Okay. Well, I'll just take a couple minutes to maybe, as best I can, define the problem or maybe define the opportunity. I'm not sure. It's probably both. So the number of ways to think about this, I mean, many of you probably read Tom Friedman's book on the flat world, and that's an element of this, you know, that to be competitive in the future, we need to be more innovative, more entrepreneurial, to create the new things rather than trying to build more of the old things. So our students need to be educated with that in mind, I think, and prepared when they leave our institutions to go out and create the new opportunities for this country to be competitive in what is increasingly a flat world. Another way to think about this is that whatever our students do when they graduate, they are going to be global citizens. And it's likely the case that most of our students during their careers will live and work in different parts of the world. And so in some respects, we're not doing them a very good service if we don't try and give them some exposure and experience with different kinds of cultures and different kinds of people around the world as part of their education. And another way to think about it perhaps is all this concern about outsourcing of jobs and everything else, and that's an element of globalization as well, the numbers of engineers that are being trained in China and India and so on. So what are engineering schools doing? And I'll try and just make some general statements. I think every university here is doing things in this general domain, and there are many, many, many different examples, but they tend to fall in a variety of buckets, I think. A number of institutions are providing summer research opportunities for students overseas. We have a program like that in China. Other institutions do. Sometimes when I talk to faculty about globalization, they say, why are you worried about that? I mean, half of our graduate students come from around the world, and all our US-born students, all they got to do is go to school and they'll be globalized, you know, because they're surrounded by students from all around the world. I don't agree with that, but that is a view that some people have. But in any case, I think we do need to continue to bring the best and the brightest students from around the world to our graduate programs. And that does provide an element of exposing our students to different cultures. Some universities have and are thinking about and are building overseas campuses of one kind or another. And these are interesting experiments, and there are a variety of such overseas campuses. Stanford has 12 of them in various parts of the world, but they're like little enclaves where Stanford students go along with Stanford faculty, and yes, they're exposed to the culture, but it's almost like they're in a Stanford classroom, and I'm not sure that's the best model. Other institutions are building partnerships with universities, MITs in Singapore, and Subra, I'm sure we'll talk about that. Others are in Europe and so on, so there are these kinds of partnerships being built. Some institutions are helping developing countries build world-class universities. Probably the best examples today are in the Middle East, where we're heavily involved with KAUST in Saudi Arabia, other universities, I think, involved with Abu Dhabi, and the goal there is to actually build a world-class institution that can become a center of gravity for high-quality education in those regions of the world. Another really interesting piece of this whole picture is distance education. You know, the truth is today that you can deliver a high-quality education anywhere in the world, any time of the day or night. And the power of the internet, all these communications technologies that all of us have worked on developing, have created the opportunity to make education remotely, make remote education much more practical and viable than it's ever been in the past. Now, exactly what we do with that, I think, is not clear. I mean, everyone's doing lots of experiments, and MIT's got the Open Courseware project. We put up 10 of our introductory courses free on the internet a year ago, and they're being downloaded all over the world. So there's lots of stuff going on in distance education, which is also part of the globalization picture. So to me, our goals in this area ought to be to provide an education for our students which prepare them to work in a global world, And secondly, to provide an education for our students which allows them to be the innovators and the entrepreneurs which are going to provide the future growth job opportunities for this country. And those are two key elements of how we should think about, I think, what we're doing in the globalization area.
Thanks, Jim.
So I want to touch on, just to amplify what Jim said, I want to touch on 4 aspects of globalization in the context of an American university, especially for schools of engineering. The first and foremost is with respect to undergraduate education. Even though, for example, the numbers that I know very well, in the School of Engineering at MIT, which is about 40% of the faculty at MIT, 375 faculty members, 43% of the faculty are foreign born. So it's a highly international group. Roughly 40% of the graduate students are foreign students. But only 8% of our undergraduate students are foreign born or come from foreign countries. So it's the undergraduates more than anyone else who need the greater global experience. And that's a challenge. There are a number of models that we have. The most successful program that has been in existence at MIT for 25 years is a program called MISTI, where every year large numbers of students, and the numbers are growing, they go abroad, preferably to a non-English speaking country. And more and more students want to go to developing countries where they engage on a project. Usually it's a technical solution, not necessarily high-tech, but a technical solution that has an impact on the local community. So last summer, about 260 students went to Africa, India, China, Middle East, to do a variety of programs. That's one model. Institutionally, there have been different kinds of models of engagement, going back to facilitator. Somebody else nucleates it, somebody else enables it, but you just nudge them along. Then advisory roles, many of us do this. And partnership is much more significant. And there are a lot of challenges in doing this, which we want to resist. For institutions like Princeton, protecting the brand name is a key issue. And as a result, an international engagement has to be taken very, very carefully. And where do we engage and where do we not engage? At the same time, let the faculty do what they want to do is a very delicate balance. One of the principles that we have employed in our international engagement, most recently, MIT's first research center outside of Cambridge, Massachusetts, which just before becoming dean, I had the good fortune to help set up. There, our operating principle is the following: to set up a research facility in Singapore that MIT faculty will engage in, and many of them will lead, under the following conditions. If you can do in Singapore what you can do in Cambridge, Massachusetts, don't go there, do it in Cambridge, Massachusetts. There has to be a unique value added, intellectual value added. So we've developed 4 programs so far, and those 4 programs uniquely bring in something that they cannot do in Cambridge. And this makes it very attractive for the faculty to engage. So that's one of the principles. The last point I would like to make is, especially for leading American institutions, I feel, given that the 21st century is going to see a greater rise of Asia, with 45% of world population, which is increasing, and the number of engineers is significantly greater there than what we are going to see here, it's partly our opportunity, but also our obligation to make sure that the future of engineering evolves there in such a way that we play a part in, but at the same time, we play a part in ensuring the quality that affects all of us. So the questions of how to define the quality, how to ensure that they meet well-established standards that have been existing in the West. So these are all challenges, and later on in the discussion, we can go into specific examples.
Thank you, Subra.
I would say globalization is one of the top, if not the top, theme of the Yale University experience. And so what makes it easier for us, and Linda alluded to this too, is to have flexible degree programs, not just ABET accredited degrees, but also non-ABET accredited degrees, or even AB degrees, that give all kinds of different flexibility to students as per their wishes for not only dual majors, but to participate in an experience abroad. think like Vince said this morning, it's not like thermodynamics, or I think Norm said it this morning, it's not like thermodynamics is any different in Melbourne or France than it is here, but it's the cultural experience of being in a different place that matters. There's another topic here that I think we really haven't touched on yet that relates to education, is that education extends, of course, beyond the undergraduate experience and throughout the graduate experience that is so important to all of our programs. And the graduate experience in engineering at the PhD level has certainly been, I think, arguably very static for however many years. You know, students come in, they stay, you know, in the lab for 4+ years, and then many of them, though, the vast majority, go on to take industrial careers, and they get involved in business and the like, and, you know, I don't know what percentage it is, but let's just call it 10 or 20%, go on to become clones of their advisors and into academia. So, you know, we're thinking hard about how do we give the educational experiences and leadership experiences to PhD students as part of their educational experience, and globalization, I think, opportunities are going to factor into that as well. Now, I think it was Vince who said that it's a little harder at Princeton to get students to go abroad because the experience is so nice here at Princeton. It's so nice to be here. At New Haven, I think we have a little less problem in offering a trip to France. But anyway.
Vince, could I? Yeah, I just, there's another model too. At Tufts, we have something called the Institute for Global Leadership, which is sort of an extra departmental institute that is well funded, and every year they select a topic. So one year it's megacities, another year it's oil and water. And I send a invitational letter out to all the students in the engineering school every year and encourage them to participate. And there are various levels of participation. You can actually take a pretty intensive course load around this topic, or you can participate in seminars, and many of our students have participated. There's a lot of people who are coming in from the globe lecturing on these topics, and then they're sending groups of students out, and it's been very successful, and our students have really benefited from that. That's another sort of model that one could use.
And yeah, just a couple of things, Vince. What I tell our students, the first time I see them as freshmen, is that when they're out there in the first job and their boss comes and says, Paul or Susan, I need you to go to Shanghai on Monday, I don't want them to go, oh my goodness, what do I do? I've never done this kind of thing before. You need to have done it beforehand. So we're trying to get absolutely as many of our students as possible to have a real serious experience overseas. In like a number of places, we've got international minors, all kinds of deluxe versions of things they can do, and then we've got other things they can do, like summer jobs overseas, and we facilitate that kind of thing. The other thing I wanted to say is putting our administrative hats on, because we're all deans, and probably it's about once a week we have either a university from overseas or even representatives from a country overseas saying, gee, Dave or Jim or Linda or whomever, we'd really like to establish a serious partnership with your institution. Well, obviously, we're not going to be arranging these things at the rate of one per week. And so we almost always say no. And I think it's really important for any university that's thinking about these things to have your list of what you're looking for. And if you're not going to get that out of it, you don't do it. And at Michigan, we think of our partnerships in one of two categories. Either minor partnerships that require very little on our side. It's more of a goodwill gesture, maybe exchange of a few students or a few researchers, but no big deal. And then on the other side, the real major strategic partnerships where over a period of years we're trying to get something very significant out of it. We have very few of those latter partnerships. One that we do have is with Shanghai Jiaotong University in Shanghai, where we established a joint institute, and it's a major thing. There are many hundreds of students there. We send lots of Michigan students there, but we had our list. We knew what we wanted to get out of it, which was a convenient landing place for large numbers of our students. We're taking large numbers of students from Shanghai that transfer into our curricula at the junior level. They're spectacular students, and we want to keep them as PhD students. We knew what the Chinese government wanted. They wanted our faculty over there teaching some courses and really establishing a different style of education in the classroom. So no longer the style that professors at the chalkboard writes things down, students copy it all, professor assigns even homework problems, students work both evens and odds, and then get A's on their tests, because that's just not enough. That might be a necessary part of the education, but it's not enough. All the teaming part and group activities and interaction with the instructors, that's the American style. That's what the Chinese wanted to see. So we were happy to provide that in exchange for other things that we're getting. And in our case, the Chinese government is really footing almost the entire bill. And I think if you check around in a lot of these partnerships, it is the government on the other side that is footing the bill, or industry, or somebody. But I think it's really important before one establishes a major partnership to have your list of exactly what you think you want to get out of it, and then make sure that happens.
Okay, thank you. Again, we'll have a chance for questions later at the end. Let's move on. And this is a topic. The next topic is one that relates to the first topic quite a bit, the engineering and liberal arts setting, I think. This has to do with interdisciplinary teaching, and in particular, the suitability of existing academic structures, which we heard a little bit from Norm about also this morning, in that context. And the designated speakers for this are Kyle and Linda. So Kyle, do you want to?
Be happy to start. So, I mean, I think there's absolutely no question that students, faculty, everyone across the board believes that interdisciplinary work, interdisciplinary teaching is where a lot of the action is, where the excitement is, and that there's a lot of momentum and certainly, effort and energy into directing our attention to thinking about teaching opportunities, research opportunities, and so on. The question is how to do it. It's very you have to try things. I think there's an experimental nature to this. You can't be afraid to try things. At Yale, for example, we created a Department of Biomedical Engineering within the last decade, and we decided to create it as a partnership with the medical school. So there are faculty appointed in the medical school that are part of that, as well as our own faculty within engineering, if you wish, that are part of that. Having a School of Forestry and Environmental Studies on the Yale campus allows us to partner with them. So we have a joint faculty member in our chemical/environmental engineering department and the School of Forestry and Environmental Studies. Being small, Yale has about 65 faculty in engineering. I think we're the smallest school of engineering at the table, and as many undergraduates who graduate each year, so also the smallest student to faculty ratio. We have but no choice to leverage all the strengths of the Yale campus, and that means interdisciplinary work with the life sciences, with computer science, which is not in the School of Engineering, with the School of Forestry, and more forward-looking things like with our School of Music, with our School of Drama, and different opportunities with the arts, which are so important at Yale. I don't know if it was teed up this way. I don't think so, but I think I would like to actually turn the mic to Vince, because when I was at Princeton not that long ago, I think some of the most interesting experiments were going on here in terms of interdisciplinary teaching, especially at the freshman level, with a new course in engineering in the modern world and an integrated program tying together physics, calculus, and biology. And so I thought it would be nice for folks to hear about how those things are coming along.
Sure. Thank you. This was not planned. Thank you. Yeah. So somewhat, although we have a larger engineering school than Yale, it's still relatively small compared to some of the other schools that are represented here. So we have also been almost by necessity quite interdisciplinary here at Princeton. And two ways that this has played out. One is at the freshman level, we have worked to develop courses that cover all branches of engineering in a more general context even than in engineering. I mean, we have, for example, courses in the Civil and Environmental Department. The names I think are something like Engineering in the Modern World, and we have another one called Structures in Society and these look at engineering problems in very general contexts. Now, the Structures in Society is very much focused on civil engineering, but the Engineering in the Modern World course, which is taken by many students from the humanities as well as engineering students, looks at a number of technologies and how they fit into how they've developed, both as businesses in terms of business context, how they fit into the societal context, what were the societal conditions that sort of fostered the development of those technologies, how they affected society, and so forth. And we start with the telegraph. We talk about the telephone, so these are electrical technologies. But we have many other technologies, transportation, the airplane, and so forth. So this is one type of interdisciplinary teaching that we have been doing for quite a long time here at Princeton. It's worked very well, partly because of, when we talk about structures, partly because there have been people who've been really passionate about it, partly because the university has put resources into it. and partly because it's been extremely successful, so it hasn't been very hard to argue for more resources for these kinds of courses. Again, interdisciplinarity also has gone up into the higher curricula. We don't have here, for example, a department of materials. I know at MIT, Subra, in the materials area. Here, materials is an interdisciplinary subject. It goes across chemical engineering, mechanical and aerospace engineering, civil and environmental engineering, and electrical engineering. So, 4 of our 6 departments are very heavily involved in materials. Almost all the courses that we offer in this area, graduate and undergraduate, are taught by interdisciplinary teams or in an interdisciplinary fashion. And so again, partly because of our size and the nature of the way things have been organized here at Princeton, we've sort of been forced into doing things in an interdisciplinary way, but it's been very fortunate for our students. I think they see a side of things that they might not ordinarily see if they were in one of these stovepiped departments that Norm referred to earlier. So thank you for giving me the chance to say that, Kyle, and maybe I'll turn it over now to Linda.
So similarly, the size-wise, we're very small at Tufts, and so we have to build across disciplines, and so that's a very much a theme of the engineering school. And we chose some themes such as bioengineering, engineering for sustainability, innovation and education as themes to rally around, and we've been hiring faculty who fit into those general areas across all departments, and it's been very successful. One of the things that I found about a small school is the collegiality is very high, and there's a collaborative spirit that that was a little bit more difficult to engender at Michigan when I was there for many years. But so what we find is people have personal relationships with each other. The faculty know each other. They see each other every day on campus, and so that helps. And so I took a little different tact on this. I had a few different models that we've used for this sort of thing. One thing has been mentioned before, which is the project-based learning. And I think in the interdisciplinary area, this is a key model that works extremely well. There's the cross-departmental, cross-university sort of type of senior design project. There's thematic types of projects like robotics, or there was a NSF-sponsored program called Bringing Engineers into New Disciplines, which was partnering with the nutrition school and the medical school to look at bringing engineers into things like developing a monitor for diabetics for them to regulate their intake of food and those sorts of things, which brought our engineering students in contact with others. We also have a theme at Tufts, which is active citizenship. We have the largest number of graduates going into the Peace Corps upon graduation, the largest number, not the largest percentage in the country. And so there's an ethos there, and many of our students are involved in social community projects as part of the design. And we have a virtual college, which is called the Tisch College of Citizenship and Public Policy, which funds these sorts of activities and gives fellowships, summer scholarships to students to do projects in the community. And that's a way to bring students together. And problem focus is a key thing, I think, in these sorts of models. Another interesting model is I brought a group of faculty together working in bioengineering and challenged them to come up with one syllabus of a course to give our students fundamentals of biological systems. And they actually did it, and we're going to launch that course next year, and I couldn't believe they came to agreement. And we have teaching assistants from every department engaged in developing case studies now for this class, and it's going to be taught from, with one person has to champion such a thing, but having engagement from all departments, I think is great. And a different model, the provost came up with the idea of having a university seminar, which was going to bring graduates and undergraduates and multiple schools together. And there was a competition, and faculty had to submit proposals. And the first one that was funded was water and diplomacy. And that course was run last year, and the Fletcher School, which is a school of diplomacy, co-taught it with one of our engineering faculty, Shafiq Islam. They had students, they had undergrads, they had grad students taking this, and they had the students separated for part of the course to give them some fundamentals in the other areas, and then they brought them together. And They've also launched something called Aquapedia now, which all the case studies from the class on all the aspects of water and solutions and war related to water and conflict and all that, all these case studies are going to be put up on the web, and it's going to be a living document that's going to keep being developed. So it's very exciting. It's very labor cost intensive for the provost to support this. There were a lot of tools that had to be developed, web tools, video conferencing, all these kinds of things. So I don't know how it'll be taught once more. I don't know if it will continue beyond that. That's one of the sustainability is an issue, I guess. The other thing that we have are cross-school majors, which kind of relates to liberal arts. Like we have a very strong program in engineering psychology, which is a partnership between psychology and engineering, sort of human factors. Those sorts of things can bring people together. And then summer scholars programs where you fund students to do research in the lab of a faculty member in another discipline, really brings the students into exposing them to other disciplines. And I guess the last thing is we haven't talked too much about extracurricular opportunities, but these abound in today's society. I mean, the Engineers Without Borders, I found it extremely interesting that the president of Engineers Without Borders at Tufts was a political scientist last year. And so we're bringing students in from all disciplines because, again, it's the problem focus. And next year we're going to be on the mall building a solar house as part of the solar decathlon, and we're partnering with the Boston Architectural College. And I was amazed to see all of the non-engineers engaged in this, the urban and environmental planners, and it was quite interesting. And their approach is entirely different based on the group of students that's assembled. So I think in my mind, there's all kinds of models out there, and there's no one size fits all. And the only issue I see is making sure that the faculty have the time to the time to pursue their vision and the resources to pursue their vision, and so.
It's always resources.
Yeah.
Anyone else have anything they'd like to say on this?
I'd just say, depending on the budget model that's used at a particular university, it can make it difficult to arrange for faculty from multiple departments, multiple schools or colleges in the university to co-teach. Everybody wants to know kind of how they're going to get credited and what it'll count for. And it's not that the faculty member's being selfish, but most faculty members don't want to do these things as overloads. And so I would admit that in a lot of cases we handle this on a case-by-case basis, and there's probably work to be done.
One of the major issues for large engineering schools like Michigan or Stanford or MIT, which may not be the same issue for schools with, say, less than 100 faculty members, is how do you bring down the walls of engineering departments, the stovepipes that Norm talked about this morning. So there are a couple of experiments that are going on. One experiment in that direction is the following. We ask the department heads every year, what areas would you like to hire this year in your department? So there are 9 departments, and we get answers to that. Then we ask them, what areas do you think the school should be hiring in? And then you put all of this information together. You find that more than 5 departments at a time typically ask for the same area. So that gives us a tremendous opportunity to, over time, try to bring down the barrier. So here is an experiment we are doing starting this year. So I have a large number of faculty searches that are in areas that the department said are of importance to them, but more than 5 departments want the same area. So we interview faculty members, but the search committee consists of members from all 5 departments. They hire the best candidate, but we ask the candidate, what department do you want to be in? And the candidates can change their department over time. And not only that, because this is an area where we would hire for multiple years in a row, when we hire the candidate, we tell him or her that if you come here, next year you'll be part of the search and you get to hire your successor or the person that'll join your group, which is a great recruitment vehicle for us. So we'll see how this process works. We don't know how it will work.
Vince, one other thing I'd mention, this doesn't pertain directly to Princeton, but it does to some other places, is places that have major medical centers have an additional just enormous opportunity for education, and it crosses heavily over in engineering. So I look at my operation, I've got about 340, 350 tenure track faculty. The medical center's got 2,000. Maybe I've got, I don't know what it is, 500 staff or something like that. They've got 10,000. And so we are very heavily involved with them, not just in research, but also in education. We've got many, many students doing projects on health system operations and things like that. So for schools that have major medical centers, they ought to use those and leverage those to the fullest extent possible.
Okay, thank you all. Next topic is integrating research and teaching. We had a little discussion of that this morning and questions for Norm's talk. And you know, the idea here is that the main principle here is how do we bring the excitement of research into the classroom? And here the designated speakers are Subra and Kyle. So Subra, do you want to lead on?
So the longest program, I want to talk about 3-4 different examples. The typical thing that most universities do, especially research universities do, is to have undergraduate students right from freshman year engage in research in the lab of a faculty member. So we have a program that's almost in its 50th year now called UROP, Undergraduate Research Opportunities Program. And the data from that program are quite interesting. It's completely voluntary. It can be either for pay, which is about $10 an hour, no more than 10 hours a week, or for credit. 85% of the undergraduate students voluntarily participate in this, and something like 20% publish a significant journal article in an archival journal before they get their undergraduate degree. So that's a program that's for research, not for classroom. Something that's related to research at the undergraduate level and for the classroom, possibly, is a relatively new model. This also pertains to innovation. About 8 years ago, we started an experiment in the School of Engineering called the Deshpande Center for Technological Innovation. And the concept is simple. So faculty are highly entrepreneurial. They go start companies, they patent intellectual property and so forth. But how do we give them a little bit of extra incentive over and above what they already do so that the process of translation from the lab to the marketplace is much faster? But at the same time, how do we give an opportunity for our undergraduate and graduate students to participate in this entrepreneurial activity? So the way this works is to have a transparent call for proposals, which is university-wide, twice a year, get all the input, and you give the faculty members a very small amount of money, about $50,000 a year for 1 year, to see if the technology has a way to make it to the marketplace. This is science published in traditional scientific journals, but to see it'll go the extra step. But during that year, we have faculty and alumni and industry friends and mentors who, if the faculty members want, can provide advice. These are people with a lot of experience in starting companies, and they've failed many times in the marketplace, which is often very helpful. And related to that is an educational activity. We put teams together. Half the team members are from the School of Engineering and half the team members are from the School of Management. In some areas like energy, we bring in people from humanities, technology and policy, taxation issues, economics, and so forth. And this is a very good educational opportunity. This also sponsors undergraduate groups that work on this. Just to give you an idea on the numbers, in 7 years, we've sponsored 95 projects involving all 5 schools at MIT. 200 faculty and students have participated in this. We've spent $7 million. It has attracted $155 million in venture capital funding. And it has spun off 20 companies in a span of 7 years. So it's an experience, educational experience that's of interest to the students. The third example in linking education and research at the undergraduate level is a new program, which is an international version of the undergraduate research program called IROP, where again we strategically take our global partners and our industrial collaborators from abroad and send our students. Not only we send them over there, but when they come back, They work on campus in the lab of a professor. And then we also engage graduate students who could be teaching assistants in this. In fact, sometimes even senior undergraduate students who could be teaching assistants in these classes. So they get the educational experience, they get the overseas experience, and they get the research experience. And the last example that I want to mention is a program that I started about a year ago. It's a very ambitious program over a period of 10 years with a $20 million gift and overall $40 million investment. It's called the Bernie Gordon Program for Engineering Leadership. And the objective is the following. How do we, in an increasingly software-based virtual world, how do we impart the real excitement of engineering to undergraduate students for hands-on, project-based, context-based learning? It's easy to do for small groups of people, but it's very difficult to do for large groups of people. So we have something called Opportunities for All, which is for all MIT students, not necessarily engineering students. Opportunities for Many and Opportunities for Few. You start at Opportunities for All, and then you move your way up to the pyramid. And it's highly competitive, but this is the first year that we have launched this, and I can discuss this in detail later if there is interest. So these are examples of activities that are relatively new and that we've been experimenting with.
Kyle?
I would say we at Yale have a special challenge just in getting students to come to Yale who want to study engineering. I mean, we're only graduating 70 students per year in engineering. Engineering and sciences at Yale, more generally, at least 400 to 500 students in every entering class that comes to Yale professes on their application an interest in majoring in science or engineering, and I can tell you that we don't graduate 400 students every year with degrees in science or engineering. So clearly, we feel that getting kids interested in research, especially in the beginning, because if you don't get on the engineering train at the first station, it's obviously very hard to get on at the second. So one of the things that was started some years ago at Princeton, Yale, woo,
That's okay, we'll take credit.
was a freshman course called Perspectives in Science. Actually, when I got there, I insisted they call it Perspectives in Science and Engineering, where they have different faculty from across science and engineering come in, one per week. And it's more than just giving a talk about research in their area. So there's a whole team of people involved, faculty in charge of the course, a whole cadre of graduate students. So it's a discussion about research in that area led by the faculty member, but there's homework crafted around it or project crafted around it. So it's more than a seminar, okay? And this exposes students to all the different exciting research going on at Yale, connects them, makes the faculty real people to them. Interestingly, the student enrollment is limited to the course, so some of the best and brightest students in science and engineering are offered a chance to take the course. Maybe there's like 40 or 50 in it, I'm not sure what the number is. So it's a real privilege to be able to take this course, and I think it's been a real help in retention issues and just getting excitement about engineering into their minds. I would say, from the Yale perspective, I've been pushing hard to make sure that we talk about engineering as distinct from science, because it is. It's not a part of science, but a partner to science. And in fact, I think I pretty much earned, from a marketing value, my first salary at Yale when I said, if you spell Yale backwards, it's E-L-A-Y, that's if engineering and the liberal arts is for you, Yale is the place. Anyway, but in all seriousness, I think, major research universities, if they don't capitalize on research experiences in their full vigor to enrich the educational curriculum, they're just wasting their most valuable natural resource.
Okay, thank you. You spell Princeton backwards, it says not Eckner.
Not Eckner.
Anybody else want to comment on this topic? Okay, so we have one more topic, and then we'll open it up to the audience for questions. And the last one is a topic that all engineers are very interested in, and this is engineering and entrepreneurship. And Dave and Jim are the designated
speakers, and Dave, you want to go first?
I think Jim should go first since he's from the Bay Area.
Yeah.
Jim?
All right. Everyone says to be competitive in the world that we're going to live in this century, we need to be innovative, we need to be entrepreneurial. That's going to be our competitive advantage. So when we think about this, it seems to me we first ought to define what it is we think entrepreneurship actually is. And to me, one of the best definitions I've heard of entrepreneurship actually came from one of our students who answered that question. And what she said was, entrepreneurship is a mindset. It's simply recognizing that things can be better than they are and that I can be part of making them better. It's not necessarily about starting companies. It can be, but it's not necessarily about starting companies. It's not necessarily about doing this or that. It's just believing that things can be better and that you can be part of making them better. A second characteristic of entrepreneurship that I think is really important is it's been described many times as a full contact sport. It is not something that is easily taught in a classroom through traditional lectures. I believe the same thing's true of innovation. Innovation is a full contact sport. It is not something that you can have someone take a class like this and me or somebody else stand up at a blackboard and give you a lecture about entrepreneurship or innovation. So if we want our students to have these characteristics, and I think we really do, then how do we teach them to be innovative and how do we teach them to be entrepreneurial? So many universities, us included, do have in fact a set of courses and seminars and lectures and that kind of stuff that provide the fundamentals of how to think about how to be innovative and so on. And those are good. They're necessary probably, but they are clearly not sufficient. So what are the key elements? And in my experience, in the things we've done, students learn how to be entrepreneurial and they learn how to be innovative by actually doing it. And let me just give you one simple example. There was a worldwide contest which was run a couple years ago, and these contests now happen every 6 months on a regular basis. The first one was organized out of our technology ventures program at Stanford, where teams of students at various universities around the world are given a project. And the project is it's usually a weekend project, so it's over a 2-day period. It's outside of normal classes and everything else. And the kinds of projects are like the following. The very first one, which was 2 years ago, each of the student teams in 7 countries around the world was given a pad of Post-its. And they were told in the next 2 days they had to create the most value that they could out of a pad of Post-its. Now, if any of you are interested, send me an email. I'll send you a site to a video of what happened in this contest. It's unbelievable, what these students did. Some of them ended up making thousands of dollars for charity through various things. Others of them, created things out of Post-its that they sold or used to solve social problems and things. It was just unbelievable what they did. And to a person, they came out of this competition being a whole lot more innovative and a whole lot more entrepreneurial than any of them thought they really were. So to me, that kind of example is illustrative of the fact that it really is a full contact sport. It really is something that you learn by doing. And so we need to provide those kinds of opportunities for our students. And generally they will be outside normal classes. I guess another important factor in this whole area to me is that unlike 10 years ago, when I talk with entering undergraduate students today and ask them what it is they want to do with their careers or what it is they want to do with their lives. 10 years ago, in the late 90s, was all, well, I'm going to be a computer science major and I'm going to get a bachelor's degree and I'm going to write a business plan and I'm going to take it up to Sand Hill Road and I'm going to get $10 million and then I'm going to do an IPO and then I'm going to retire. And this all happened by the time I'm 22. And in a few cases it actually did happen, but in most it didn't. Today when you ask them this, they say, I want to do something with my career and my life that has an impact. I want to do something that makes a difference. And when you ask them, what do you mean by that? They say, I want to work on global scale problems. I want to work on alternative energy. I want to work on the human health issues. I want to work on the environmental issues and so on. So wrapping the experiences that we give them to help them learn how to be entrepreneurial and innovative around these kinds of global scale problems is a match that I think has tremendous power and tremendous implications for getting young people excited about engineering. So I am a real believer in entrepreneurship and innovation. I think you can teach this. Some people think you either have it in your genes or you don't. Maybe that's partly true, but I think you can teach these things. And I think young people can become much better at them than they think they ever could be. And we need to set up structures and things in our curricula and outside our curricula that will give students such experiences.
I had Jim go first because I just wanted to say ditto. I'll say just a little bit more, but Jim is absolutely right about sort of his definition of entrepreneurism. It's all about creativity and innovation. It's not that every student needs a startup or wants a startup. And Jim is also right about learning by doing. Trying to become an entrepreneur by just taking formal coursework and reading a few books would be like trying to learn how to play basketball by reading a book. You might know some rules, but you really have to do it. And so for a university that wants to be successful in this area, you need curriculum, yes, but you also need programs. Another comment I'll make, and I'll try not to upset too many people in the audience who might be from the business community, but I think at a lot of schools we've too long left entrepreneurship to the B schools. And in my place, we have had a long-standing relationship with our business school. It's a terrific relationship. And we have had joint entrepreneurial programs with them for a very long time. But those programs were attracting mostly engineering students in industrial and operations engineering because their curriculum was already kind of halfway vectored to that of a business school. We found it necessary about a year and a half just to start our own programs, not as a substitute for, but in addition to what we were doing with the business school. And within a year, we had a student entrepreneurship group with 800 student members, and now it's bigger than that. And we've invited students from all across campus in the engineering entrepreneurial programs. So we've got plenty of students from business in our programs. And I think that's okay because in almost every case that I've witnessed, at least in my corner of the world, the idea for the company came from an engineer. They needed business expertise, they needed help from the business side, but the ideas came from engineers. We've got lots of engineering students who are fully capable of doing the whole business piece, and so if that's what they're capable of and that's what they want to do, then I think we ought to facilitate that. Some specific things we do, actually, we've got, in my case, about 5,000 alums that are in the Bay Area, California. And quite a number of the famous companies out there were started by Michigan alums, and in many cases they picked up a master's degree at Stanford before going on to the startup world. But we get our kids as connected as we can with those alums. And in fact, we take a plane load of our students out every spring break. Instead of those kids going to Florida or students going to Florida, we take them to the Bay Area. And they spend a week with our alums getting an entrepreneurial boot camp. I was with them a few weeks ago, and my students pitched 30 different companies to the alums. And so that was a great experience. And we also do some things that get campus-wide attention. Last fall, the student organization at Michigan in entrepreneurship, they launched a competition called 1,000 Pitches. And they were actually looking for ideas from more than 1,000 companies. It's pretty ambitious to try to come up with that many ideas in just a few-week period. But they did it, and every submission was a video submission. So it was the students talking about their idea and what have you. And then, as you can imagine, these were judged, and there was a big dinner and that sort of thing. But a whole bunch of these things are turning into companies. And a bunch of them are not, but that's fine. The students were dreaming, they were creating, they were thinking about possibility. The last thing I guess two other things. One is that in addition to entrepreneurship, I've got a number of my alums clamoring that we in engineering offer something that might be called a mini MBA. Just 2 or 3 courses would cover topics like corporate finance, accounting, marketing, and some others. And I've got so many alums giving me exactly the same list, I'm starting to believe that maybe we should do this. We probably will do something like this, but we won't do it alone. We'll get the business faculty to teach a lot of this for us. But what I'm seeing is engineering crossing over more heavily than ever before into the business world. The last thing I'll mention is coming from the state of Michigan, where the economy is probably the poorest among any state in the country. We have a huge economic imperative at my university to transform the economy of the state of Michigan. And so we're taking that very seriously. And so in addition to our entrepreneurial activities, we do a lot of recruiting of firms to Ann Arbor and that sort of thing. And this all mixes together very well. So we're doing more with industry than we ever have, and the entrepreneurship is just one piece of that.
Thank you. I don't want to cut this discussion off too prematurely, but I'm looking at the clock, and I want to be sure that we get a chance for the audience to ask questions and make comments. So why don't we move to that phase now, and let me open it up to you. Anyone who has any questions or what have you, just want up here.
Question about marrying two ideas. One is the teams of interdisciplinary students, and the other is international partnerships. But as background, before I get to that, I just want to say something about problem solving. It's often been said that engineering is about problem solving. I think most people would agree with that. In my experience, aerospace and then Wall Street and now not-for-profits, the benefit of problem solving wasn't the solution often, it was the process. And so my idea, and I haven't heard any of you quite touch on this, is maybe you have 3 students from the University of Michigan, 3 students from an engineering school in India, IIT, say, and 3 students from one in Germany, and they form a team and you give them a problem. And I see the interview with those students afterwards. On the plus side, if it's a big success, the kids in Michigan say, yeah, the guys from Germany came up, I never would have thought of it that way. They thought of it, they came at the problem entirely differently the way we did. Or you interview the students afterwards and it was a bust, and the kids from India say, well, you know, those guys in the United States, they didn't think that this was important at all. Well, that makes you a great reputation, appreciating what's not important in other parts of the world, products that you create. So you've touched, a number of you, on different ideas, including the competition, but I think those 7 teams were all at the same university. And I'm trying to suggest different thinking from different...
It's actually a really interesting idea, and we've tried that experiment actually, where we had a year-long design course, actually in our mechanical engineering department, where there were teams at Stanford and there were 2 other teams in Europe. Not one in Asia because of the language difficulties, but and the results were mixed. Some of them were spectacularly successful, some of them were a bust, but it was a really interesting thing to do, and it had many of the attributes that you described in terms of benefit for the students.
Along the lines of what you just mentioned, the Lemelson Foundation is funding a program to have students from American universities interact with students from one particular IIT, Indian Institute of Technology in Madras, to go to do a project jointly in different villages in South India. And I don't know how successful that program is, but I just heard about it a few months ago.
Frank?
I just comment, we're doing that with Tokushima in Japan at the University of Colorado with mixed results, and one of the biggest problems is schedule. Just, it's
Right.
not getting back and forth to have the students talking to each other. Their course schedule, their semester schedule, their exam schedules and so forth, they're so different that turns out to be a real difficulty in doing it. But we've been doing it on the IT of Tripoli Future Energy Channel.
Take another question here. Carl.
Yeah, I'm very fascinated, of course, with all the buzzwords that we always hear. We heard from the politicians, change is necessary, and then all the politicians say innovation is going to solve all our problems, even though they don't know what they're talking about when they talk about innovation. We talk about leadership, we talk about entrepreneurs, we talk about innovation and so on. These are all good things, but the overall work or the overall contributions that are being made in industry are not simply done by entrepreneurs or by leaders or by just innovators. And there's something which we could call followership, or maybe a fancier word for it would be a team player. And people, I always like to quote Peter Drucker, who said, the idea is great, but only if you work on it. And the working on the idea is where we do not just need a number of leaders, but we need a leader and then a team. We are not teaching probably our students how they can change sometimes rather than being a leader, because they're being assigned to a product team or to just a development team. There can only be one leader, because if they're all leaders, they will never get to the point that they make a product that they can sell for a profit. It's not as fancy or as sexy to say, yeah, I'm a team member or I'm a follower, okay? But we should do that, and I have seen that as an example in the course that I'm teaching, where I concentrate mainly on the process of the innovation rather than just the idea. We start with a case study, and I divide the who is going to do what at what time, so that we actually get to the result, namely on December the 4th, they have to present the case study. How do we get this in there somehow?
I think it is in there. At least at my place, we start that right away at the freshman level. We have student teams doing exactly the kind of things you're talking about. And then we also, outside of the regular curriculum, have some very large student projects. We have a large a solar car student team. It's more than 100 students, and yeah, there is one leader, and it's a student. And there's a whole organization they build. They set the schedule. And they build a completely new car every 2 years. They race it in North America. They race it in Australia, et cetera. They have to raise $2 million for each of these cars. They do all that themselves. And it's not just engineers, it's engineers and business kids and people that can predict the weather, and et cetera. And so, at least at my place, students are getting a lot of this. I will say that this is more recent. 10 and 20 years ago, it wasn't that way.
So Mark?
I'm curious, many of you touched on the crossover between engineering education and business education. Probably the center of that is in product discipline. And I can tell you that I see a lot of engineers graduate from the university level and go to a corporation, could be large or could be small, assigned to a design team. But it's much more than aesthetics. Sooner or later they figure out there's usability, there's market segmentation, there's cost constraints, there's environmental impacts. They're in product management before they know it. Then they're in product planning, then they're in product marketing. And so my question, I guess, for undergraduate education is, what focus is there on incorporating the training and the education surrounding the products and the management and the construction and building of products into the core curriculum as opposed to simply technology?
Maybe I can take a cut at that. I mean, a number of universities, Stanford included, have specific programs in product design that have many of those attributes, but they don't, or at least historically have not reached out and impacted the broader group of undergraduate students. So I think in a number of places, ours included, one of the goals we've had is to take those kinds of experiences that a subset of students have had and to make opportunities for a broader set of our students to have that kind of an experience. So the example I described earlier of the D School, we're bringing together these interdisciplinary teams and working on a problem. These problems very often have the kinds of attributes you described. There's an industrial mentor, there's a real goal and objective. They have to really worry about creating something which has a decent business plan, which has performance, reliability, and engineering sense, and so on. So, but it comes from bringing these different kinds of people together and wrapping them around a project which in and of itself requires those kinds of characteristics in the project. But it's a challenge to do that. These kinds of things are very intensive in terms of faculty time, in terms of how you structure them, and so on. So it's to scale, to find a model which is scalable to large numbers of students is a challenge. I mean, many of these experiments you can do with a half a dozen students or a dozen students. To do it with 500 students, is quite a different story, and to figure out a model which is scalable.
So why us? I think you hate.
I'm very inspired by all the great programs and initiatives that you have shared with us. At the same time, I'm very intimidated by the fact that this is supposed to, at least for the undergraduates, have to happen in 4 years, to cram everything in here. And so I'd like to hear from you a response to Dr. Augustine's thought this morning that this perhaps is not a 4-year education. And what are your thoughts about preparing a good engineering students for this nation and for the world in more than 4 years, so that they can have some social life and grow up during those years of 18 to 22 and have this great global experience and collaboration and innovation and hands-on experience and basic science and basic engineering and design and so on and so forth. So I'd like to hear from some of you as to what you think about 4 year or more than 4 years.
You takers?
I've got a pretty strong opinion on this, and it's grounded in the fact that an engineer is not just one thing, not just one type of person. We've got students who graduate who go on to do extremely technical work, other students who go to medical school, other students who go into marketing, students go into business, students to do all kinds of things. I think there is room in those 4 years for a lot of what we've said, and it's not that every student needs to do every last thing we mentioned. And there are some students that will take a more technological version, and there are some students that will take a less technological version. Now, if you wanted all the technical depth, plus all the other things we're talking about, yeah, then you're talking about a master's degree. And we have a master's degree, and so that works fine. The other thing is, in a lot of cases, you can kill multiple birds with one stone. And so we work hard at my place at arranging summer jobs for students overseas. Good. They get the international experience. They also get to earn some money. They also get to learn something technologically. And a number of these things sometimes can be combined. But we're not just trying to train one kind of person, and we're not insisting that everybody have exactly the same kind of experience and check off every single box among these things we've mentioned.
If I, as somebody who took 5 years to do his undergraduate degree, maybe I'm well qualified to comment on that. At that time, I thought it was a complete waste of my time in one of the IITs, and then a few years later, after I graduated, the IITs went to a 4-year curriculum. I think the real stumbling block for us in that a lot of students go for a 5-year program, volunteer for a 5-year program, but the stumbling block there is not the unwillingness on the academic enterprise or on the part of the students. It's the cost of undergraduate education. And I think we, especially in private institutions, until we address that in a serious way, that is going to be an issue.
So can I make one quick comment on this? I don't think about this in terms of a 4-year problem or a 5-year problem. I think about it as a career problem, because I really believe that engineering education needs to be a lifelong commitment and a lifelong experience. And so the concept, I agree almost completely with what Norm said this morning, that all these things are important for students and so on, but what I don't agree is they all have to be crammed into them in 4 years or even in 5 years. I think we need to educate young people who are lifelong learners. I mean, look at the way people learn nowadays. And they don't go to libraries anymore. They search on Google for something, and it's amazing what you can find and what you can learn, through online learning. That's only going to get better. So I think in many respects, our students need to have the fundamentals, obviously, but the fundamentals include some of these other things we've been talking about, not just thermodynamics, et cetera, et cetera. But they most importantly need to have the ability to, and a commitment to be lifelong learners, so that as they need to learn new things, they will know how to do so and they will be good at doing it. And so I think of this as a career problem, not as a 4-year or 5-year problem.
There's a question up there at the top.
Thank you, sir. My name is Xin Xiao. I came from China 3 months ago from the Institute of Process Engineering, the Chinese Academy of Sciences. And I agree with David's introduction of the Chinese government attitude to the education in the university. But the things in our institute is a little bit different from those in the universities. With the rapid development of Chinese economy, there are a lot of opportunities we obtain to establish a very good relationship with the companies. And this relationship offers us a very good opportunity to transfer our engineering innovation in the laboratories to the market. And we have a lot of chance for our PhD or PhD students to practice. So we have a chance to realize the project-based training. But problem is that how to improve those students, their engineering research, innovation capability. I would like to have your suggestions. If you have some good suggestions, it will be very high appreciated.
Takers?
Based on my visits in Shanghai, what I tend to see there is the university research is high quality, but it is more like what used to be done in American industry. A lot of the research that, at least that I've seen, is not what I would call basic research. And I think that the Chinese government really wants to foster more basic research. And to do that, they probably obviously need to fund basic research, but they may need people that have been trained in slightly different ways. And I think that that's going to be a process, and that's going to happen over time. So there's no question. Earlier I was commenting mostly on what the Chinese government wanted to get out of this sort of educationally at the undergrad level, but they're absolutely looking to change the research operation there. And I think that that will happen. In the case of the Joint Institute that we have in Shanghai, they're hiring their own faculty. And this is a different kind of faculty member than may exist at some other Chinese institutions. These are people who are being hired to do basic research.
you have some experience that improve the students' research ability during the practical process? For example, do they transfer the technology to the market during this process, improve the students' research ability? Do you have such examples?
Well, I have examples here in the U.S., but I'm not familiar with what is or is not happening in China in that area. Yeah.
Maybe I could just amplify on a couple of comments various panelists have had relevant to this question and the earlier question, and that is that, we can't really teach everything in the university that engineers need to know. I mean, in the very least, there's a period of apprenticeship after you leave the academy. If you're going to be a researcher, you become a graduate student, which is like being an apprentice to a researcher. If you're going to be a design engineer, you go into a company and design, and you learn from other engineers. You just don't learn these kind of things from books or from professors, really, unless maybe it's research. If you want to be an entrepreneur, you've got to get your hands dirty. So I think that, a lot of these questions are how do we do this in the academy, but I mean, ultimately it really is, as Jim said, a lifelong process. You get out there, you learn from people who are already doing this, masters in the field. And it's very much like the medieval guild, if you will, where people are learning from people who do. And I think we can't do everything in the university. And many of these things are things that we can foster, we can encourage our students to get out there, but at some point we have to rely on the whole engineering enterprise, the whole community, to bring along the new generations. It's not just about what happens in places like this. So, yeah. Frank, another question?
One question, one comment. I chaired the committee on looking at the 5-year program for ASWE, and the basic situation was the hiring community wouldn't support the 5-year degree, and most schools dropped it. And it was just simply that there wasn't enough salary differential from the 5-year graduate and the 4-year graduate to pay for it. The question I wanted to ask is, in your internationalization programs, how do you deal with the issues of corruption and honesty?
We deal, our largest international program at the present time is with the government of Singapore. And you can judge for yourself with respect to corruption in that government. It is an issue we constantly face, not only the issue of corruption, different interpretations of ethics on a day-to-day basis. What is legal here may be severely illegal. When our students and faculty go spend extended periods of time, what is the potential for liability of different kinds? Will it be a negative learning experience if the students go there? So the MISTI program, for example, which has been in existence for 25 years, before the students go, in fact, my own daughter, who's an undergraduate, spent last summer in Europe. Before she went there, she had about 4 different sessions with the faculty sponsors and staff in this program on language preparation, cultural preparation, learning about the geography, and things like this. That doesn't quite get to your question about government integrity. So at least in the several programs that we've been involved in, it took about 1.5 years for the agreement to be signed. It went through about 4 different layers of legal screening on our side. We hired a lawyer on their side. We hired a local lawyer in the foreign country, and we paid for them. They worked for us. We wanted to make sure that there were no we didn't get caught in the legal cross currents or crossfire. Not only the integrity part, but taxation issues, a huge thing, especially for a large program with well in excess of $100 million. So it's not easy. The program that I was referring to earlier, the Research Center, personally, it took 12 trips on my part, exactly half a world away, over a 12-month period. And it took legal teams on both sides. And also it took a lot of discussion, faculty discussion on our side, do's and don'ts.
Yeah. You know,
So it cannot be taken very lightly.
Yeah, just a quick comment. I don't think the issues we deal with in terms of corruption and anything are fundamentally any different than corporations as they internationalize their operations. I mean, I'm on a number of corporate boards, and these kinds of discussions come up in the context of how to do business in country X or country Y, and they're really no different for universities. You have to establish a corporate culture, or you have to establish a university culture and set expectations, both for students coming here and for people from here going there, and just say what they are and adhere to them. It's the same for companies as for us.
So mindful of the clock, I think maybe we'll cut the discussion there. Thank you all for participating. It was very interesting. And let me just say that now we have refreshments down in the convocation room. There are a number of students down there eagerly awaiting you who want to talk about some of the things they've been doing under the aegis of the Keller Center. And you know, our panelists will also be there, so if you have further questions, let me encourage you to buttonhole them there. So thank you all again. Thank you for coming, and we'll see you down there. That's fun. Thank you. I got to come to taking notes. I'll go out.
It's good. Well, in our institutions, all different. So somehow some things make sense for some things.
We don't have to.